Hello everyone, welcome back to the follow-up tune-up episode on the 6BM8 amplifier, as promised. And when I build an amplifier, one of the things I really like to do is listen to it for a while and let everything burn in. I know that's a real controversial topic, but I really feel that I can hear a difference in especially the coupling capacitors and the tubes after they've been run for 4, 5, 6 hours. I don't buy into this thing where it needs 200 hours before they're broken in, but I do think from power on to about 5 or 6, 4 or 5 hours, 6 hours, something like that in, there is some changes in the way it sounds. So I don't jump to any conclusions based on what it sounds like when it's first powered up. Plus, I think listening to it over time, you can pick up the subtleties of things that you may not like or would like to see changed. One of the things I have done since the initial build is I changed out the Solene capacitors for these Mundorf aluminum oil caps, these EVO caps. And I really like the way these caps sound. I know you can spend $500 on coupling caps, but I feel like these Mundorfs are a good kind of middle ground between your generic yellow polyester caps or the little Solenes and the higher end audio caps. These aluminum oil caps are about $15 a piece, so they're not real expensive, and they're a reasonable size. Some of the audiophile caps are so big they'd never even begin to fit inside this amplifier. But anyway, changed out these Mundorfs. I really like the way they sound. I think it's a little more detailed is probably the best way to describe it. And it was a worthwhile upgrade, I feel. So the next thing we're going to look at is I feel like the amplifier could use a little more drive. It's off of my DAC. You have to turn it up to probably 3/4 volume to get a decent listening level. And I'm using some pretty efficient speakers. There's some little Clips Icon KB15s. And so it's not that I'm not using efficient speakers. And I also want to add, and this is going to be the topic of my Monday monologue this week, any tuning that I'm doing to my gear is for my living space, my speakers, and my source. This amp might sound great, just like it is in your environment. But in my environment, I feel like it needs a little more drive. And I also would like to try to address the little bit of ringing that I saw in the scope on a square wave. So I'm going to go over the two things that we're going to be changing today. One of them, and here's on the schematic, you can see, the two things we're going to be dealing with are this unbypassed cathode resistor. Now, when you have a resistor on the cathode of a tube that is not bypassed by a capacitor, it's basically acting as a little bit of negative feedback. And when you put a capacitor across this resistor or bypass it, it will give more drive out of the plate into the next section of the amplifier, but you lose some of the negative feedback. And the design that I copied some of this from used an unbypassed resistor here. And as you can see, it's around 1.3, 1.4 volts around in there of bias, which is then negative bias through this grid leak resistor to the grid of this first tube. What we want to do is put a 0.7 volt diode with a smaller value resistor in series on this cathode. And what that's going to do, a diode acts like a bypassed resistor, but it gives a cleaner sound and gives a little more detail to the amplifier. And so I'm going to be using one of these little 7 volt. I'll link the part number in the description below. And in series with that, we'll play with different values of resistors until we get back to this same voltage that we have currently on the cathode of this tube, and then go plug it in and see what it sounds like. Hopefully we'll get a little more drive out of it. I'm probably also going to check it on the scope before and after and see how much peak to peak voltage that we get out of the speaker jacks with and without this modification, to see if we've actually increased the power output. The other thing is this amplifier has got a lot of attention on one of the do-it-yourself forums, and there were people arguing about, like, I spec'd a 5K output transformer, and there were people saying, "Oh my God, that's totally wrong. You need a 7K. The world's going to end." And long story short, one of the guys that breadboarded it tried all different resistances of output transformers and determined that a 5K output transformer, like I was pretty sure was ideal for this, gave the most power with the least distortion. I think one of the things that confused some of the people, they were using formulas and cheat sheets about like what voltage on this tube do you need this output transformer, and they were doing it with this tube in pentode mode, and we're running it in ultralinear, which needs less resistance on the output transformer than it would if it was in pure pentode mode. The other thing interesting when somebody simmed this was that they put a small capacitor across this resistor right here, and like a 10 PF, and it helped the ringing. So we're going to try that as well. So the two places we're going to be working is this little resistor right here. Let me see if I can zoom in here. We're going to be working with this little resistor on this lower one down here. This is the cathode resistor. And then this is the shade feedback resistor that we're going to put a capacitor across. So I'm going to start setting that up and maybe start the camera back when we get the scope going on where we're at, do the modifications, and then show the after effects. So let me flip all this off and we'll be back in a minute. Okay, got the amp all hooked up on the scope with the isolation transformer, dummy loads on the speaker jack, have my signal generator and my oscilloscope hooked up to the outputs. Now, when we're looking at the scope here, this top line is the signal going in from the signal generator, and this is the output for the amplifier. And the signal generator is set to 0.5 volt per division, and the output set to 2 volts per division. So I want to show you what's going on here and why I want to try to increase the input sensitivity. When we start turning up the input signal, when we get to right there is 1 volt peak to peak, and we're getting out right at 4 volts peak to peak on the output. But as we turn up the input signal, we're still not seeing any clipping. And we're still not seeing any clipping. There's clipping. Just starting to see clipping on the output of the amplifier. And to drive the amplifier to clipping, we have to put in 1/2, 1, 1.5, 2, 2.5 volts peak to peak, which is way past what any source is going to be. And to really drive this amplifier to full power, you're going to have to drive it with a preamplifier, which defeats the whole purpose of having this small amplifier. Now, I'm not going to deny that it's going to sound better at a lower signal input and a lower output, but you can still get to right about there, and the waveforms are very similar. So I think we could get some more power out of this thing without getting into distortion by increasing the input sensitivity. The other thing that we want to work on, and I'm going to switch now to square wave. If we look at, this is the input square wave, and it's nice and square and flat. You can see some ringing here on the front end of each one of these waves. There's a little overshoot and a little bit of ringing. And I think by putting a capacitor across the shade feedback resistor, we can reduce this ringing and hopefully not round off this front edge too much. So those are the two things we're going to be working on today. I'm going to go ahead and put those components in and then come back on the scope and show you what the changes did. Okay, first mod we did is we have installed this diode plus ended up with a 270 ohm resistor in place of the 1K resistor that was on the cathode of the input triode. And I think we've got some success. I'm going to first show you, we're turning up the volume, and here is the input that's set on 1/2 volt per division, and the outputs set on 2 volts per division. As you can see, they're right there together at full volume, and they sit on top of each other at like 7/8 volume, and should be relatively distortion free and sounds good, which it does. So I'm going to switch these over to the other channel which we've modified, and now when we turn the volume up, we're at the same 2 volts out at just shy of 3/4 volume, and at full volume it now goes that loud at 1 volt in. So we've increased the input sensitivity and therefore the output of this integrated amplifier just by changing that 1K resistor on the cathode of the input triode to a combination of a diode and a resistor. We could probably get some more power out of it by putting a LED that was the same 1.2, 1.3 volts rating. The problem is I found that gives a really sterile sound to an amplifier, and also the LEDs, like the infrared LEDs that are that low of voltage, around 1.2, 1.3 volts, they just don't sound very good, at least the ones I've tried. If somebody has a 1.2 or 1.3 volt LED that they've used that really sounds good, then I'd love to see it in the comments if you want to say that. And again, I'm going to put this little Cree diode that's a 0.7 volt drop in the description with the part number, and that plus this resistor I think gets where we want to be. And I'm showing you right now what it looks like installed in the amplifier. So I'm going to go ahead and do the other channel before we do the other mod with the small 10 PF capacitor bypassing the shade feedback resistor. I want to plug the amp in and listen to it and see what it sounds like. Never do 2 mods at once, because you don't know which one did what. One of them might have worked, and then the next mod that you did at the same time ruined the sound, and so you think maybe both of them are a bad idea. So I've learned this through my different careers and different things I've done in my life. Never modify 2 things at the same time. But as you can see, at just shy of 3/4 volume, we got what we had at full volume before, and it's still just as clean, and I bet it has a little more detail. Before we jump off of this, I want to switch to the square wave and make sure we didn't make this worse. And we didn't. It looks exactly the same as it did before. Still got a little bit of ringing here on the front end, and we're going to try to tune that out with a capacitor across the feedback resistor. So anyway, I'm going to finish soldering this up, go plug this thing in and listen to it for a little bit, and then come back and continue with the mods on this amplifier. Okay, we're back now from listening to the amplifier after we did the diode resistor combo modification to the cathode of the input triode. That's a mouthful, but that was a huge win. Listen to it for about 30 minutes and it's clearer. It's got crisper details, but it also gave it a giant amount more volume than it had before. So that was a win-win-win to me. So the last thing we're going to be looking at here is doing the modification to the shade feedback resistor circuit. And it's something I've never done before. Someone on one of the do-it-yourselfer forums simmed this thing and said, give this a try and see if it doesn't help with the ringing you're seeing. And I'm not sure I've ever seen anyone bypassing a shade feedback resistor with a small capacitor, but here we go. We're going to try it. And as you can see, I've got zoomed in on the scope. This one up here is the output from the signal generator. It's nice and square. And you can see on this one, there's some ringing here on the front end. It's not real bad, but it's there. So I've already modified one of the channels. This is the unmodified channel. And let me switch to the other channel. Okay, here's the other channel. And as you can see, putting a very small, it was a 10 PF 500 volt mica capacitor. You need to make sure it's a high voltage capacitor because this is on the plate of the output tube. So it's got, I forgot what the plate on this runs at, 200 something volts. Anyway, as you can see, it's a little rounded off, but the ringing's gone. So I'm going to modify the other channel and then go listen and see what this modification sounds like, and then we'll finish up the video. Well, I just got back from listening to the amp after we put in the bypass capacitor on the shade feedback resistor, and it sounded horrible. Even though it looked like an improvement on the scope, and so when somebody simmed it on the computer program Spice, they thought that this is going to fix the problem. It sounded like I put a blanket over the speakers. It was terrible. And so the moral of this story is you've got to listen to your amplifiers and trust your ears. Some of these things that we see people talking online about, try this, do that, and all they're doing is running computer simulations on it. Until you actually put it inside an amplifier and listen to it, there's no telling what it's going to sound like. So don't be afraid to experiment with changing values and adding and changing components inside your amplifiers, but just make sure you only make one change at a time and then listen to that change. If I had done both of these at once, I wouldn't have known which one ruined the sound of the amplifier, and I would have had to undo some of the work just to see which one was causing the problem. So clearly putting this diode resistor combo on the cathode was a huge win. The amplifier's got a lot more power. It's not even, I'd hardly call it a flea power amp anymore. It'll drive you out of the room with these little clip speakers. Again, all this depends too on the system that you're using, what you're using to drive the amp, and what you're listening to it through. Some less efficient speakers might not work as good. Some that maybe were not as bright on the top end wouldn't sound the same as these clip speakers do. So here's the final schematic done. We're finished. The only change from the last time is we've added this diode resistor combo, which is this little Cree diode with a 270 ohm resistor, and the voltage changed from 1.3 to 1.2 volts on the cathode. Not a huge change. So I hope you've enjoyed this series. That's probably it for this 6BM8 amplifier. It's pretty much done. And I hope if some of y'all build this little lamp, you enjoy it as much as I have. And now I'm going to even more since this little modification. And in my downstairs basement area, this little amp with these little clips, KB15 speakers, and a topping DAC hooked up to my computer just sound really good. And I think you'll agree if you do decide to build one of these. Hope you follow my channel. Please subscribe if you haven't already. Like my videos. And I look forward to seeing you on my next build, which I think is going to be some sort of a clone of Dyna ST35. Have a nice day.